Right, hi everyone. So I'm going to do a quick demo of Karl. So Karl is an experiment in language design, which I started around Christmas. And yeah, my friend Nicolas has joined me as a contributor and is contributing to feature and examples now. And we've got pretty decent number of examples at this stage to use Karl, and we also have a VS Code plugin, which you will see in action in this video. Yeah, and Karl can do a decent number of things now. So if you want to try it out, yeah, please do and have fun. Okay, so I'm going to start with very simple things. So with dot syntax here, which materialize as a list of integer between 0 and 10. And so to run a program in Karl, you do Karl run and you give the path to the program. So yeah, we get a list of integers. One thing to note is that the return value of a program, of a scope, of a function, of a block is the last instruction in the block. So there's no need for explicit return keywords. Another thing that you can do with this dot syntax is to specify a step, right? And so if I do this or this, yeah, you got the idea. And this also works with chars. So I can do this, for instance, and because we have an expression here, we can assign it to a value, to a variable, right? So I get exactly the same thing here. And because R is a list, then I can use a couple of functions that are defined on list. I can pass a closure to that. And so I will transform each character. I will map each character of the list, transform it to a string here, and then call the toUpper function on it, and then we get a list of uppercase. Next thing we can do is, let's say I want to take the 5 first elements of that list, and I get with this. So that's it for some basic stuff. Now I'm going to show some example of import, like we're going to import code from this helpers.k into the main.k file. So what I'm going to do is I'm going to define a top level in that helper case, and I'm going to define a function called delayed, which takes an argument delay, and in this function I'm going to use a built-in function which is called HTTP, and this function, this built-in HTTP, is part of our standard library, and it accepts an object literal with some field, and with those fields you can express any HTTP request basically. And so here I'm going to use this service here, http bin.org, and in particular I'm going to invoke the get delay endpoint. Alright, that's it. And so yeah, this helper function defines two bindings, x and the delayed function. And now I'm going to import those top level binding into the main.k file. So for that, I just because they are at the same level. Just need to say import helpers.k. And so if I execute again the main program, we see that this import file expression returns a module factory, which is the thing that we can see here. And a module factory is nothing but a fancy name for a function that lets you instantiate, basically. So this import returns a function, a module factory, and using that module factory, I can do things like helpers. And so here I'm calling that function, that module factory, to get an instance of this environment. Basically, like I will create a scope out of this file, basically. And why we don't do that? Why the import doesn't do that automatically? Is because you may want to create multiple instances, right? So if I do this and I log h1, h2, h3, right? I get free scope, free environment here, and I can define each one independently. Okay, I can do this, and then we get like three distinct. This import cannot return anything else than a function in Karl, because this function, you need to call it to create a fresh and completely isolated environment, basically. So that's how it works. And now I'm going to remove that. It was just for the example. And also here, so this is a syntax to define a function in Karl. Because we have only one parameter, we don't enclose it in parentheses. But if we add multiple arguments to that function, right, we would need those parentheses. And because we have only one instruction, we can actually remove completely the enclosing braces. Yeah, and I can have that. And in Karl, like like already said, like the last instruction in a scope, in a block, in a program, in a function, is the return value of that scope, of that function, of that program. No need for explicit return keyword. So let me create an instance again, and now I'm going to call that delayed function, and I'm going to call that delayed function with a delay of 2 seconds, and I'm going to log here that we have reached this point of the code. And so if I execute this, the program doesn't terminate immediately. It waits for 2 seconds until the service returns, and we get the printed statement done, which we expect. Okay, and so now what I'm going to do is refactor a little bit this code to make use of the for construct. So in Karl, pretty much everything is an expression, but many languages have everything has expressions as well. It's not new to Karl, but in Karl we also have for construct, which are expression. Yeah, what I'm going to do is I'm going to reuse the range syntax, the dot syntax, and then I'm going to create a for loop that iterates between I and r dot length. And so in Karl, that's how you create a for loops. It's a for expression. It initializes some bindings that will be used within the loop, increment them, and then this is how Karl manage the return value of the loop. So basically, when the condition of the loop becomes false, the then block, which is here, is automatically entered. There are other cases where this block is automatically entered. It's, for example, when we break with no values. If we break with no values, we immediately enter the then block, whether or not the condition is true or false. And finally, when we break with a value, then that value becomes the return value of the loop. There's also cases where the loop is infinite, and in that case, the expression returns a unit, which is immediately assigned to the value. Yeah. And so what we're going to do here is I'm going to extract a delay from this range using the I variable. I'm going to log that, and here I'm going to log that we are in the then block. And it's a block, so we'll return a value. We'll return the value of I. And at the end of the program, we're going to log value. And so I'm executing this program, and we are iterating through each element of the range. Finally, we enter the then block, and the value that we return is 4 because I has a value of 4. Actually, maybe if I just print I here, it makes everything a little bit clearer, hopefully. Okay, so now what we're going to do is we're going to call this delayed function, but we will use the value of the range array as the delay argument. Let's just use elements between 0 and 4, so 0, 2, and 4. And here we're going to log the value of I, and I'm going to re-execute. So yeah, we call the same function 3 times, but each time passing a different delay, which is increasing. When we enter the then block, and then we return the value of I. So it means this HTTP function is actually blocking, right? But what if we don't want to block? For example, we want to execute that in the background, right? And not wait for it. So the way to do that in Karl is to add an ampersand in front of the function call. So when we do this, here we will get a task under. We get a task under here. And then, because this call won't be blocking anymore, immediately we will see this log. And that means that actually the program will exit almost immediately, right? Because there's nothing that blocks the program. So maybe that's not exactly what we want. Maybe we still want to block the program. So what we're going to do is add a wait. And we execute this program. And now yeah, we're blocking again because we are waiting. Because we are waiting, we will get the response for this HTTP service by using the return value of the expression wait task handle, basically. So the response of the service is available here. So this is what we want to get. Oh yeah, type, sorry, not response. So the service is called, and we returns, and we get the response of the service. So an HTTP function always returns the same thing. It returns an object which has headers, status, and body. And so here, let's say we are interested in the body of the function, so I'm executing this. And yeah, we'll get a response which is pretty similar each time, like it's always the same except the URL changes, as you can see. And this field also have a different value between the different calls. So what I'm proposing to do, just for the sake of completing the example, is that we will extract this value from the HTTP response, and then we'll concatenate all of those values, and we'll return that as the program main return value. So how are we going to do that? Basically, what we're going to do is we are going to use another built-in of the Karl programming language, which is Decoding JSON. So on this body, we use Decoding JSON. Right, and from this JSON, in this JSON we have a header field, and in this header field we have this field. So what I'm going to do is I'm going to traverse the JSON object to this property, and I'm going to call that amzden, and then I'm going to log that. Okay, so doing that, right? Okay, and now I'm just going to add this value to a list and return that list. And so I'm declaring a new binding, which is a list, and now I'm going to add amzden to that list, and then I will return that list, and that will become the value return object. And this we can just return it. Okay, so that's we get what we were expecting, and now I will just finish on that. So it's an important point actually on Karl, because this syntax, which returns the list as part of the then block, means that those braces here define a block. But actually this syntax is very similar to another syntax, which is an object literal with a shortened property, which would be equivalent to writing this, right? Having a field name hack with a value named hacked. And if you define an object literal with a shorthand property in this way, it's very similar to a block, right? I mean, it is like a block. So you need a way to disambiguate. You need a way to say that this is a block that returns the list simply, and it's not an object that would contain a shorthand property hack that would return the value of hack. And so there's two ways to disambiguate in Karl. First is to add a trailing comma. So if you add a trailing comma, there's no ambiguity for the language. So we're going to do that here, and we're going to see the difference. So before we were returning a list, and now we return an object which has a hack property which contains that list. And the second way to disambiguate is to have at least one field that is explicitly named in this way. So here there's no ambiguity as well. It cannot be a block. It has to be an object literal. So it works in the same way. And it's worth mentioning because in Karl we also have computed blocks. So with this syntax, you actually define a computed block where the last instruction in the block is the return value of the block. Right, and here we get the same thing as before. And that's pretty much it for this demo. So this is a very, this is a program that is not very interesting, right? Like, if anything, it helps showing some of the feature of the language, but we actually have a great contributor to the project recently, like Nicolas has joined, and he has implemented many of the common algorithm that you can expect to be able to implement in a new programming language. This works really well, and it's complemented with this workflow demo, which is a set of demo that shows advanced feature of Karl. And so I'm going to run one of them. So the example contrib workflow enhance demo, and is showing many things, like how you can orchestrate a workflow of tasks which can be sequential, parallel, or expressed as a directed acyclic graph, and you have retry mechanism, many other things. Like this is a great set of samples that gives you a glimpse of what Karl is capable of. Also, for each feature of the language, or probably not covering 100%, but very close to it, there is a features directory which has example program which shows exactly one aspect of the program. Maybe one last thing is that Karl parse, a command lets you print abstract syntax tree of the program that you just written, so you can inspect the abstract syntax tree as well. That's it. I hope you enjoyed this video, and feel free to join us and report issue, give it a try, basically, like if you like it. Thank you very much.